So today is day 11 of the advent of code, and this one is going to be fun because what they've set up is a lovely little cellular automaton, very much like Conway's Game of Life, although with a number of very interesting constraints and differences. So here, let's take a look at it. This is a seating arrangement thing. They presume you've landed at an airport and there's a bunch of chairs there, and the chairs are situated on the floor in a bizarre way. So you see this bunch of L's and dots. Well, L's are seats. You notice they look like chairs, the profile of a chair. Okay, and the dots are floor. There's no chair there. So the rules are that people will sit in these chairs based on very simple rules. And here are the rules. If a seat is empty and there are no occupied seats adjacent to it, and that means in the 8 surrounding cells, then the seat becomes occupied. If a seat is occupied, and 4 or more of the seats adjacent to it are also occupied, then the seat becomes empty. Otherwise, the seat state does not change. We are not tracking how people get up and move. This is really just a game of life. Cells come into being and then go unbeing. You know, they live and they die. It's like the way Conway's Game of Life is run. Okay, so then they give us a little acceptance test, and the acceptance test looks like this, right? Here's the original seating arrangement. Lovely. Okay. And then after the first round, it should look like this because all those seats get occupied, right? Because they're empty and none of the rest of them are got anybody in them, so they all get occupied. And then, of course, there's too many people sitting, so a whole bunch of them get unoccupied. And then this continues on for a few more rounds until it finally stabilizes in this arrangement, and after this, nothing changes. And the quest here is to drive the automaton until it stabilizes and then count the number of occupied seats, which they say is 37. Now, all they want us to do is count the number of occupied seats. But it seems to me it would be interesting to actually see the automaton working. Now, first of all, we're going to solve the problem. We'll get to the 37 here. We'll solve the problem. But then, well, why wouldn't we actually watch the automatons? Maybe we can figure out a way to get it on the screen. Anyway, that's my ambitious goal for today. Let's see if I can actually pull that one off. Okay. All right, so let's begin this project. So what is our first test? Well, probably what we should do is go get that acceptance test data. So let's go get that stuff. Okay, and that's this thing here. There it is. And that's what the input is going to look like. In fact, let's go get the actual input and see what that looks like. Okay, that's going to be pretty interesting, isn't it? All right, well, we're going to go get that, copy that, and we'll make that go away. That's fine, and let's go get it and put it in our input. So we'll just say create a new file named input, and we'll paste it in there. Good, and fine. Now we've got that. Okay, now let's go get the much simpler one, which is the the input for the acceptance test. So here's our test data here. It's these L's and dots. Let's go get that. And we're going to take it over here, and we're going to say, let's see, what is it? Define the test data as that. Perfectly fine. Let's put a line end on the end because I expect line ends on the end, generally speaking. And slide over here. And yes, I know that's ugly, but I'm not going to mess with it because it's just a bunch of data. Okay. Now we need a test. And what should we test here? Well, it would be nice if we could test that we could parse this nicely. Sometimes, that's getting a little bit ahead of the game. Often I would like to do the businessy kinds of rules first, but I wouldn't mind parsing this because you see, I'm going to need a way to get test data into this program, and probably the easiest way to get test data into this program is by parsing lines like that. So let's do that. Let's test that we can parse. So we will describe the parser, and it can parse one line. Seems reasonable. Okay. And now should equal, well, I don't know what it's going to equal yet, so okay. Parse line, and let's say, well, degenerate case, nothing. Now, I know what that is. That should be a list with nothing in it. Why a list? Or a vector, I should say. Well, I presume that when we're done parsing everything, we're going to have a vector of vectors of something. So that should be fine. And if we go down here, we see that, oh heavens, this did not work because I don't have a parse line function. So let's write the parse line function. And this should be a string, a line, and a line, good. And we're going to parse that line. Okay, to parse the line, we're just going to walk through the string character by character. And yeah, I think this is going to be really straightforward. Map v, because I want a vector to come out. And the function I'm going to map it over is going to be equal L, yeah, capital L, %, right? So that would be the character L, and then the line. Okay, well, if I run that, it passes, which makes perfect sense because I didn't pass anything in. So let's do a few other examples. Should equal true of parse line L. That should work. Yes, that works. And I'm not going to do too many more of these because it's kind of obvious that it works. But let's just say should equal true, false, true. Of the parse line of L dot L. That should also work. Okay, I believe that is sufficient. Now all I need to do is parse the entire thing, and that ought to be pretty straightforward as well. So let's get another it here. Another it is fine. Yeah, okay, fine, good. It should parse the whole input. Okay, and should equal, and let's say true, true, false, false, true, false. Yeah, okay, that looks good. And let's break that into two columns like so. And now let's say parse input. So that would be ll dot backslash n dot l dot backslash n. Let's just make sure that that's in there. Lovely. And that won't work unless we have a parse. So let's define parse input to be the input. And this is pretty straightforward. Let's let the lines be string.splitlines of the input. Yes. And now let's say that the I think I don't need to do that as a let. I think I can do this way. Map the parse line lines. I think that's going to work. Let's see. Oh, yeah, that works just fine. Okay, so now we can parse our input. That's really all we wanted to be able to do. And now we should be able to focus on some business rules. So we're going to describe the automaton, the cellular automaton. Okay. Simple rules, guys. Simple rules. Okay, so it should follow. Okay, what is the rule 1? Let's take a look at the rule 1. Rule 1 says if a seat is empty and there are no occupied seats adjacent to it, it becomes occupied. Okay. Should occupy empty seats according to the rules. All right. So, first one should equal. All right. Now it gets interesting, right? So this is going to be dot 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 dot. That's really kind of the smallest thing we can look at, because the only way to get a cell to be not empty is for that cell to be surrounded by a bunch of empty cells. That is the rule, right? Let's look at that rule again. A seat is empty and there are no occupied seats adjacent to it, then it becomes occupied. So the result should be this. There should be someone there once we are done. And now we want to do one turn. One turn of the automaton. What do we call that? Cycle the automaton. One turn. Okay, let's just do how about that? Update automaton. And we're going to parse input. And the input is going to be dot 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 backslash n dot 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 backslash n dot dot dot. That should be a bunch of empty seats, and one seat should appear. Okay. Well, this doesn't work because we don't have an update automaton, so let's make that. All right, this is the world, and we're going to call it the world. I know it's the seat layout, but I'm going to call it the world. And what am I going to return? Nil. Okay, so that should fail because we return nil. It does. And now I'm going to make it pass by returning this. Expected, false, 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 false. No, 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 no. Oh, look, I don't have... that's interesting, isn't it? I want to be able to read that. Well, that's interesting. So, I think I should change my my thing here. I think I should change that to look for dots, because dots are, oh no, L's are empty and hashes are full. And dots are floor. Ooh, a little more interesting than I thought, isn't it? This is not just binaries, is it? Huh. Okay, so let's back off of this. I want this test to not be true, right? I want this to be empty. And I want this to be empty floor. And let's turn that into this and person. Empty floor person. Okay. Now those tests are going to fail again. Right. So now let's make Parse Line work again. And Parse Line, well, that's going to be interesting. So I'm going to make a new function, which is decode cell or parse cell. Okay, fine. That's easy. Define parse cell. And this is going to be a character. And cond p equals char. Let's see. Backslash L is going to be, what did I say? Empty. And backslash dot is going to be floor. And backslash hash is going to be person. Okay. Now let's see what happened. Yes, the parsing of the one line worked fine. Now we need to parse this one down here, and that's going to be, let's change the input a little bit. Let's make that like so, and this is going to be empty, empty floor. And this one is going to be floor, empty, person. Okay, and did that work? Let's go check it. Yes, that worked too. Now we can parse the whole input. So now we should occupy empty seats. This failed, and this is correct, right? So I want this here to turn into that. Right, okay. Well, okay, so that should be this. And yeah, that's correct. Okay, so I want to say this, right? I'm going to get that, and I'm going to put that in here. And that should make everything pass. And everything passes. Lovely. Okay. Well, this is interesting. I don't, of course, want that as my output because that would be stupid. But this is test-driven development, right? And you do these potentially stupid things initially. Why did I do that? Well, because I now know that my test passes. So I have tested my test. All right. The next should, and these shoulds are going to be a little bit ugly. So I'm tempted to write a special function here. Let's do this. All right. Should match. Should update or should what is it? So here's what I want. I want the starting state and the ending state. That's what I want my assertion to look like. And should transform, should automate, should become. There we go. Should become. Not bad. Okay. And I want to say should equal end state from the should equal the parse input of the end state and the update automaton of the parse input of the start state. Yep, okay. I don't think I've broken anything there. And now this should become and now we just have to balance the parentheses and get rid of all this gunk. Okay, should become, and now we just balance the parentheses, right? So, ding, ding, something like that. And let's see if that works. It does. Good. Let's just check it to make sure that it works. So I'm going to put that as a hash and make sure that it fails. Yes, it failed. Good. Okay, so I'm going to make that a dot again and make sure that it passes. Good, 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 good. All of that worked. Lovely. Should become. So what's the next should become? Next should become... Okay, dot, 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 person dot, 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 should become, and now, I think this is going to be dot, person dot, backspace, dot, 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 line in dot dot dot. I think that doesn't change, right? Because the center space does have someone next to it. And this one here is not overcrowded yet. And so I think that's fine. And yes, this fails because we're doing that. So now we actually have to do something intelligent over here. All right. So what is the intelligent thing? Well, what I want to do is count the neighbors, count the occupied neighbors of a particular cell. So, I think I can write that this way. Map v I'm going to have to walk through this array. It's a two-dimensional array, so I'm going to have to walk through the two-dimensional array. So doing a map might not be the right thing because it just does one-dimensional arrays. And I'm really going to need to be able to look around. For row in the range of count, this would be the column or the row, count world. So that's the number of rows in the world. Yep, that's right. So, yep, okay, let's do this. So for row in the range of count world, yes, Bob, yes. For, because remember we're going to return a list of lists. So for returns a list, and the inner for is going to return another list. So this is going to return a list of lists. For column in the range of count, and now we want the nth world row. I think that's how you do nth, isn't it? Nth is the collection first, so world, and then row. Okay, so that should give me my two variables that I need, the row and column. Good. Okay, so now if cond p equals, and now I want the character. I want the occupation. So this is going to be the cell at. I wonder if there's a way to do a two-dimensional lookup into a vector. Let's see. Let's call this get cell. That would probably be better. Okay. And get cell we're going to say is row column, world row column. Okay. And now we're going to say that this is going to be the nth world let the row be the nth of the world row. And then this is going to be the nth of the column of that particular row. And, I mean, everybody's going to know what that R means, but maybe this should be row index. And this should be column index. And this should be row. This is row index. Yes, I should have used the rename. And this should be the column index. Okay. And I'm going to trust that this one works. I could write a test for it, but that seems like a little nonsensical. So I'm going to get my cell here. I'm going to compare it to, and then look for this. Actually, I didn't want to do that, did I? I wanted to count. I wanted to count the neighbors. And I didn't want to do a cond p either. All I wanted here was if count people, it's the people in the chairs, of the world at row and column, and what I want to know is if that's equal to 8. All right, if that's equal to 8. No, I'm not counting the people. I'm counting the empties. Count, and it's not even count empty. Count no people. Well, so let's just count people. Count people. I think count people is fine. If that's equal to 0, and the thing I'm worried about here is that floor and empty seats are both not people, right? So if no people are around my particular coordinate, row and column, then I'm going to return from this if statement a person. Otherwise, I'm going to return whatever it was already, because it might be a seat and it might be the floor, and I don't really care. Now, by the way, I could say, I could check for a floor first. I could, you know, and by the way, I better, because, yeah, there's some cases here I need to be worried about, aren't there? By the way, I've done this incorrectly over here as well, because I want that to be an empty seat. I definitely don't want a floor to suddenly have a person on it. So I want this to be an empty seat. I want that to be an empty seat. I want to make sure that this empty seat does get occupied. And I want to make sure that this empty seat does not get occupied. Good, Bob. Good. Yes, this is right. So if the count people equals 0, that's good, except that I don't want to do that if we have a floor. So So I'm going to look at this, and if I have a dot, then I'm going to return a dot, because floors return floors. That's it. If you're on the floor, you get a floor. Okay. And if you are an empty seat, yeah. Boy, Bob, you know, these aren't characters now. These are the real things. So floor returns floor. Yes. And empty's going to return this. Okay, so it's either going to be a person or empty, and it's only going to be a person if there's nobody around it. And if it's a person, well, we're just going to return a person for the moment, because I'm not going to even look at the deletion of people yet, but that is coming. Okay, so now we need count people. Well, okay, count people. And you'd think, well, I should write a test for count people. Oh, hang on a minute. I've kind of got a test for count people if I can put this together easily. Count people, world, row, column. Okay. Well, okay. So the issue now is that I want to look at okay, let's go index. Row index and column index. Be consistent about this. For okay. I'm going to back off of that. I don't think these are indexes. I don't need to say that. What I've got now is R in rows and C in column. Okay, so this is going to iterate, and I don't remember how it iterates again. Which one is the first and which one is the second? Does it matter? Well, no, that's not how I want to do this, is it? So that's an index. And I want to go from the index minus 1 to the index plus 1. So I'm looking at... Oh, no. I got to do minus... Oh, yeah. Okay. So, here, you know, best way to do that is this way. So I got this, right? And I'm looking at this guy right here. And what I want to do is get the coordinate of that guy, 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 that guy. All right. And to do that, I need to take the row and subtract 1, and then use the row and then plus 1. And I need to do the same with the column, right? Subtract 1 in the column, and then the column, and then plus 1. So I need to do both of those. Okay, and I think I can do that this way. R is going to be the range of from dec row to inc row, and that's one too few. Because range, if we look at it, range of 1 to 3 will give me 1 and 2, right? So I'm going to make this inc of inc row, which I know that's ugly. Okay, fine. And then we're going to say C is going to be range of dec column and dec inc of inc column. And I put a square bracket in there that shouldn't be in there. Okay. So that's going to run me over the entire range of 9 cells. Count people. Maybe that should not be count people. Maybe that should be count neighbors. Right? So count neighbors. Yeah, okay, fine. Count neighbors. Doesn't like the spelling of that. Yeah, because I misspelled it. N-E-G-H neighbors. Yeah, okay, fine. H. Okay. Okay, now there's a bunch of conditions I need to worry about. I don't need to worry about them for this test. Well, maybe I do. I don't know. So, yeah, I'm going to have to worry about these conditions. So, what are the conditions? That does not look right. What seems to be the matter with that? There's the paren there. Good, I need a closing brace. Lovely. Okay. All right. And then I should probably close the for loop this way. Is that the closing of the... No, that's the closing of a range. So, yeah, I think I've got a problem there. Okay, that's probably better. Okay, that closes the for loop. That closes the function. Okay. In essence, what I want to do is something like this. If get cell world RC is equal to person. I want to count the neighbors. What am I trying to count? Yeah, person then we're going to return a 1, otherwise a 0. Right? And that means that I could take and return the reduce plus of all of that. So where's my reduce? Yeah, there's the for loop. And let's make sure that, yeah, okay, fine. So I want to add up all of the cells that are people, that have people in them. Fine, 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 fine. Okay, but I can't do this if R is negative or C is negative or R and C equal row and column. Right, and I also need to check that it's not larger than the bounds of the world, right? So let's get a few variables here. Let row max, row count, be the count of the rows. Be the count of the world, which is the count of the rows. And let the column count be the count of the first of the world. And we're assuming that the world is rectangular. Is that a good assumption? Well, let's take a look at our input data. Yeah, where is the input data? There it is. Is the world rectangular? And yes, it appears to be rectangular. Okay. So we will assume that the world is rectangular. Okay, now. Now what I want to do is put a bunch of guard clauses in here. So let's say this, cond neg r gives us a 0. Neg C gives us a 0 because there's no neighbors out there, and greater than row count, and that's greater than or equal to row count. Zero. Greater than or equal to call count, C, 0. I'm writing way too much code without a tester. And otherwise, this one, and otherwise else 0. Okay. I believe that's going to work. Now, it didn't like row count, and that's because I did not put that properly. Good. Is everything updated? Yeah, okay. Let's take this for loop and do that with it. That really didn't help very much, did it? Let's get rid of the reduce plus. Yeah, I know. And let's say that that brace goes to the end down here. And what we're really saying is neighbor counts. Let's see if I can spell neighbor. Okay. Neighbor counts is equal to that. And then this is going to be reduce plus neighbor counts. Okay, that was a lot of code without a test. Let's see what happens. And oh heavens, horrors. Unable to resolve R. Where? Line 19. Oh heavens, look at that. I think that's supposed to be row, isn't it? Excellent. Now we have a result. And what did we get? We got floor, person, floor, floor, person, floor, 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 floor. And which one was that? Oh, that was floor, person, floor, floor, person, floor, 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 floor. All right, so the second one expected floor, person, floor, and so we expected floor, person, floor, 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 floor. Yeah. Floor, person, floor, 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 floor. We expected this. This is what we expect. This is what we started with. And what we got was floor, person, floor. So what we got was floor, person, floor, 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 floor. Got floor, person, floor. So we got a person here when we didn't expect it. So the count somehow went to 0. So, boy, it's hard to read this, isn't it? Hard to read this. So looks like the first one worked, right? So if I take this one and I make it go away, then yeah, that one works. So it's the second one that's failing. That's interesting. Now the second one says, no, you can't make that one be a person because there already is a person here. So I should have gotten here. I forgot one step. Yep. Okay. Equals row equals R row. And there's an and here. Equals R row equals C col. And that one is going to be a 0. Because you are not your own neighbor. Okay, now. That still did not fix it. What did we get? We got floor, person, floor, floor, person, floor, 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 floor. So it still did put that person there. And it should not have. And by the way, that should be an L. That should be a seat, an empty seat there. Right? Can't get these right. So I expected floor empty, and I got a person. Now, why did I get that person? Well, Bob, let's actually see what this thing returned. I got myself a bunch of zeros. Oh. Every one of them was 0. This apparently did not work. Right there. That apparently did not work, even though there was a person there. We assume there was a person there. Yeah, because there was a person here. All right? So, count neighbors obviously returned to 0, and it put a person in. So why did count neighbors return to 0? It got all zeros here. So let's look at what it's looking at. And we have to use a do for this, which is unfortunate, but that's how you have to do it. And now we can say println R and C. And get cell world R and C. All right, so what did we get? And yeah, I get it. There's a bunch of junk there, but we can look at this one because that's the interesting one. So floor, person, floor. We did get a person there. We see the person there. 0, 0, 0, 1, 0, 2. Good. Floor, empty floor. That's right. Floor, floor, floor. So it is looking at it correctly. All right, and then we say, well, if it's negative, it's a 0. If it's negative, C. Okay, what's C? By the way, does it ever go to negative? Oh, but the only one I'm going to look at is the one for count neighbors. That's the only empty seat. So yes, count neighbors only gets called for the empty seat. So yes, makes perfect sense. That's why I'm not getting any negative numbers here. Okay, fine. Floor, person, floor. Oh, look at that. Did I return from the wrong? No. Here, let's do that, just so that I can distinguish them nicely. Okay. Yeah, something's definitely wrong with that because neighbor counts should not have some list in it, although the way these things work, you're never quite sure who's printing what and when. So let's do this. Let's make sure that all of the laziness is done before we print neighbor counts. There we go. Okay, that's better. Yeah, I mean, if you don't know how laziness works in Clojure, you're going to get these funny, weird order issues because it defers the execution of lists unless you force them with something like that. Okay, so the neighbor counts. The last one is the one I'm interested in. Floor, person, floor. Yes. Floor, empty floor. Yes. Floor, floor, floor. Got it. Neighbor counts 0, 0, 0, 0, 0, 0, 0, 0, 0. All right, so we get the right number of counts, and we have the right things there. So this was apparently not functioning. But the get cell world RC, get cell world RC, was pulling back person there. So why did what is this? What? parenthesis. One too many parentheses. Okay, no change. No change. Floor, person, floor, empty floor. Yep, okay, and still got this. So I wonder which of these... row count greater than or equal to R? Yeah, okay, Bob. Out of order. There's all these people, yelling at me. Bob, you idiot, you got them out of order. Yeah. Okay. Oh, there we are. All right. Okay, now. Oh, and I broke something, and of course that was the println, because there was a brace at the end of the println. Yes, okay. All right, get rid of that one. Yes, okay. Now, you can join that one, and 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 all of this should work. Yeah, okay, all right. So, that was fine. Let's see. Any more things that we should do about occupations? Yes, let's just try a few. Like, let's try the corner cases. So let's say that I've got an empty seat there and nothing but floor. Right, so it's an empty seat, and that should not change. Well, that's a very interesting question, because it is not surrounded by people. So that should become that. That should become that. It does. Okay. What else should I check? The person in the middle should remain. Might as well check that. It's a reasonable thing to check. Should become and it does. Okay, I think that's all there is to check on that. All right, now let's do the empty seat problem. It should vacate surrounded seats. And what is the rule here? The rule is 4 or more. 4 or more, then the seat becomes empty. So, if we have then that should become right. So there's 5 seats, and then the rest is floor. And that seat right there is surrounded by this guy on the left and these guys above. And so the guy here should just become an empty seat. Now this fails. Okay, and it should fail. How are we going to make this pass? Well, okay. If there is a person there, and if, and this is not equals 0, this is going to be greater than or equal to 4. So if 4 is less than count neighbors, so if 4 is less than count neighbors, then it's still a person. Otherwise, it's empty. And that's only if it was a person before. Right? Oh, and I did something horrible. Too few arguments to if. So I probably did not. Yeah, okay. It should be a paren there. And it should not be a paren there. And okay. Now this broke more than one thing, so I'm a little confused by that. Because this should only have affected the case of a person. But it's probably this less than sign. I probably screwed it up again. If 4 is less than the neighbors, then the person can remain. If the number of neighbors, now, if the number of, here, you know what? I can't think about that in my head, so I'm going to just do this. Okay, at least that made only one of them fail. Okay. So if it's 4 or more, it should become empty. All right, so what about equals? Let's do equals 4. For the moment, equals 4. Because that should work in this case. It doesn't. Not only doesn't it, so if the neighbors equals 4, then that should be a person. No, it shouldn't. If the neighbors equals 4, then it should be empty. Otherwise, it should be a person. Okay. Now, why didn't this pass? Because it should have passed, right? Because I had a person, empty person. Wait. What is this? Vacate surrounding seats. Person, empty. So this empty has 4 people around it. Exactly. 4 people. And it should become, and I got person, empty person. Why did this one get, oh, he's got 4 around him too. Doesn't he? Oh, Bob, headaches. Yeah, 1, 2, 3, 4. Yes, he does. So that should be, all right, let's make sure that it is the right thing to do. I only want this one to have 4 around him. So let's make that one a floor. So now he's got, this L has got 1, 2, 3. Okay, so I want that to be a dot. And I want this to, well, in fact, let's do that. Okay. So this middle guy here, he's got that guy, that guy, that guy, and that guy. That's 4. That's exactly 4. And but do any of the others have 4 around them? This guy's got 1, 2, 3, but not 4. This guy's only got 2. This guy's only got 2. So I think that one's gonna pass. Ah, yes. All right. Good. 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 Okay, now let's do the greater case. Well, how about this? What should that become? Okay. Is there anybody that does not have 4 around them? No, they all have 4 around them. Yeah, they all have 4 around them. I wonder, does that work? This does not work because they're not exactly 4. So now, if the count of the neighbors, you know what? I hate this. Put that 4 over there so that I can actually see it. If the count of the neighbors is greater than or equal, then that should pass. Got it. Too many arguments to if, so I probably got something wrong there. If, what did I do wrong here? Yeah. So, if the count of the neighbors is greater than or equal to 4, then it should be empty. Otherwise, it should be a person. So what did we get? We got person, empty, 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 person, empty, person. Is that really right? So this guy's got 1, 2, 3 around him. Oh, yes. So he is still there. This guy's got way too many. This guy's got 1, 2, 3 around him. Yep, okay. So he's going to be okay. And the same is going to be down here for those, like that. It's very difficult to work this out in your head, isn't it? Ah, that worked. Okay. Well, I think I've got enough to do the acceptance test here. Okie dokie. So, how do I do the acceptance test? Should become. Oh, that's a whole world, isn't it? So, let's do the acceptance test. Let's see. Should solve problem 1. Okay? And now what we're going to do is we're going to say, this is it. And we're going to have a bunch of tests here because we've only got a little bit of this working so far. So, it should solve problem 1. So we're going to say should become, and we're going to read the input. So that's the test data. And the test data is going to have to be, well, the test data is right, so that is the way that works, right? So test data should become test data. And then what's the output? So let's go here. And it says, after one round of these rules, every seat in the example layout becomes occupied. So let's try this. So this will be step 1 of the test data. And test data should become test data step 1. Ah, that worked. Yes. Okay. Now. Okay, so it's definitely doing that correctly. Now, what we don't have is the solve function. So, and what did they say? 35? 37. Here, let's do this. Count people. Do I have to count people already? No. Count people at test data step 5. That should be 37. Might as well put that in there, right? Okay, so count people is pretty straightforward. Gee, filter, count, filter, pound equals person percent of the flatten of the world. Got 0. If I flatten the world, parse input. Yes, okay. So now all I need to do is solve this thing, right? So and let's say we're going to solve the parse input. Solve 1. So this is solve problem 1. And let's call this count people when done. Count stable people. Count stable people. Yeah, okay. Kind of like that name. Count stable people. I don't think they'd count me. Okay, count stable people, parse input of test data. Yeah, so this is the original test data, right? So we're going to count that. There is parse input. Okay, count stable people. Woo, okay, here we go, guys. Define count stable people. given the world, which is parsed already. Okay. This is kind of like a repeat until, right? You know, I just want this to go until it does not change. Okay. Well, loop. World. Okay. Pretty easy. And now I want to know what the last world was. World. Last world. Nil. Ooh, that's interesting. If equals world, last world, then we return the count people of the world. Yeah, that's it, right? Otherwise, we're going to recur what is the name of that function? Update automation. Update automaton of the world and the world. Okay, that worked. Okay, so now we should solve the problem. Okay, that took 0.1 seconds. All right, fine. So now let's create the solution. It's going to solve problem 1. So equal nil of the count, stable. You can type it, Bob. You can. But you can also use IntelliSense. Good, you know. I'd rather just type it, though. Count stable people of the parse input of the input. Input. I think there's an input. Don't have an input. Where's my input? Oh, yes. Oh, no, I know. Well, here. Let's make input, right? Let's do that. Yeah, def input is slurp input. That way we don't have to mess around with it. Okay, fine. Okay. Yeah. Okay. Oh man. Okay. It took 9 seconds. It's gonna be fun to watch that one, isn't it? And the answer is 2418. All right, let's see. 2418. Is it 2418? Is it 2418? All my acceptance tests pass. It should be 2418. Let's see. Oh, that's the right answer. I got a gold star. I don't even know what it looks like, but I got the right answer. Okay, fine. Fine. So the answer was 2418. And it took it 10 seconds to solve it. Which, okay. Now, you know, maybe not the most efficient way to solve this problem. It's not too bad, though. I wonder how many iterations it went through. would be interesting to find out, wouldn't it? Let's count the iterations, guys. Let's count them. Okay, so I'm going to say iterations 0. And here I'm going to say inc iterations. Ooh, and here. You know what I'm going to do? Right there, if, yes, this if right there. I am going to do something horrible. Do something horrible. Do. Because you got to use a do. Because, you know, ifs just want one form. Println iterations. Let's just see how many iterations that took, just because I'm really curious. All right. Oh, look at that! How many? 11 seconds. 71. 71 iterations. Wow. That was just 71. So it's really taking a long time to go through those. How big is that array? How big is that array? Bob? Let's go see if we can find out. It's definitely there. Of the slurp of input. Okay, so I'm in the right namespace, and I'm just going to say that, and bing, bing, bing. Yes, it's definitely there, so let's go get it. So this is going to be the define of world. Yep, okay. Got my world. Now I'm going to say count world. This is the number of rows, 98. And now I'm going to count the first of world, and this is the number of columns. So 10,000, roughly, 98, 96. Something under 10,000 cells. And so we iterated that, how many times? 72 some odd times? 71 times, so that would be 710,000 cell operations, taking me 11 seconds. So, yeah, whatever. That seems a little slow to me. Ought to be faster, I would have thought. Anyway, let's get rid of this nonsense now. Well, we know the number of iterations. Okay, Bob. We satisfied our curiosity about the number of iterations. Let's do a little bit of cleanup here. Yeah, that can probably be cleaned up even more. I know. You don't like parentheses at the end. Everybody hates parentheses at the end, except for me. I think that's kind of cool, actually. I've gotten used to it. The do here does not need to be there anymore. I put that in for a print line, and I can probably get rid of that now. Okay. Let's see. Real careful. Yeah. Okay, I'm just kind of looking it over, making sure that I didn't leave anything stupid in here. I mean, okay, all right, and let's join those lines. Good, everything still works. Of course, running these tests now is kind of expensive. In fact, it's so expensive to run these tests that I might just turn off that last test there, because that's a lot. But okay, all right. End of phase 1.